Our face is extremely expressive. We use facial expressions to not only express our thoughts and ideas, but also convey our emotions. And understanding them is fundamental for nonverbal communication. Also, facial expressions could be the only way to communicate for people with physical disabilities. So how about monitoring these facial expressions and using it to their advantage? This is where strain sensors can help. In detecting the facial expressions, we can gauge whether a person is experiencing pain. Such strain sensors can be paired with rehabilitative devices to help people with mobility issues. So it helps to determine how comfortable a person is in using the rehabilitative devices and the training modes. But wait, what is a strain sensor? It is a device that is used for measuring the amount of deformation of a material by detecting the changes in the electrical properties. Now, traditionally, strain sensors are rigid and fragile in nature and can be stretched up to just 5%, which is a tiny bit. There are many researches done in developing stretchable and flexible sensors. However, their fabrication techniques are quite complex and expensive. For a sensor to be applied on the face, it needs to be highly stretchable, biocompatible, skin-conforming, flexible, as well as highly sensitive to detect the small changes, with simple and low-cost fabrication techniques, as the sensors will be disposed of after use. So here comes a research where we have developed stretchable and flexible strain sensors, where we have used an unconventional substrate material of temporary tattoo paper with conductive carbon ink as the sensing element. And these can be used to detect the subtle changes on the face when an emotion is expressed. We have employed a straightforward and cost-effective fabrication strategies where we have done the patterning of the conductive ink onto the tattoo paper with the help of a stencil of the sensor's straight line pattern, and we applied the ink using an applicator brush, and then we transferred our sensor onto the skin. See, simple. We've also modified this slightly to include an ancient Japanese technique of paper cutting and folding called kirigami, which is a variation of origami but with cutting involved. Here we used scissors to make alternate slits on the folded tattoo paper to create the kirigami structure. And then we evaluated our sensors based on their electrical and mechanical performance. The results showed that our sensors could electrically respond to the stretches with good accuracy, and we were also able to achieve a 35% stretch on the skin for the kirigami-inspired sensors, which was greater than that of our normal straight line pattern sensors, which was of 20% stretch on the skin. Also, since our substrate material, which is the temporary tattoo paper, is so thin, thinner than a hair strands, it could very well adapt to the skin structure with good self-adhesion. And it was also biocompatible as no reactions were caused on the skin. All these results are crucial to develop strain sensors that are to be applied on the skin. And with further optimization of our sensors, they have the potential to improve the quality of the current technology in the healthcare field to better cater to the people in need. Thank you.